Let's take a look at some more stoichiometry examples. We're going to do mole to quantity and reverse examples. All right, so we've got our example right here. H2SO4 plus 2NaOH gives us Na2SO4 plus 2 H2Os. There would be a 1 in here and a 1 in here to ensure that it's balanced. Step 1, balanced chemical reaction. That's your step 1. Always need that. Step 2, let's identify what we know. What's our known? We have 0.350 moles of NaOH. So NaOH is 0.350 moles. Good, so we've identified our known. Step 2, what do we want to find? What do we want to find out? Well, sodium sulfate, mass of sodium sulfate, that's this guy right here. Sodium sulfate, we want to find out the mass of this. Good, we know what we want to find. Step 1, balance. Step 2, identify our known thing. Step 3, what do we want to find out about? Step 4, map it. Okay. So here's our map. We know our moles of NaOH, right? 0.350. 3 significant figures. Then we go from our moles of NaOH, then we can go to our moles of Na2SO4. So then we can go to our moles of Na2SO4 using our molar ratio. And we have 2 moles of NaOH, 2 moles of NaOH to 1 mole of sodium sulfate. Then we can go from our moles of sodium sulfate to our mass of Na2SO4. We do that by using our molar mass. Okay. Then we do our conversions. So the mole-to-mole conversion based on our chemical formula is I write out how many moles of Na2SO4 are there for 0.350 moles of NaOH if it's 1 mole of Na2SO4 for every 2 moles of NaOH, right? That's our molar ratio. 1 mole of Na2SO4 for every 2 moles of NaOH. So I do 0.35 times 1 divided by 2. 0.35 divided by 2. 0.175. There we go. Now, you can probably logically deduce that answer out much quicker than writing it all out. I still write it all out for you to show you what we're doing and to show you that my Na2SO4s go on top, my NaOHs go on the bottom. Now we go from moles of Na2SO4 to our mass of Na2SO4, and to do that we are going to need our molar mass of Na2SO4. So Na is 22.990 times 2 plus S is 32.066 plus O is 15.999 times 4, Na2SO4, 142.042. So I'm going to do this conversion where I go from our moles, how many moles we have of that, to our mass of that. So we go like this. How many grams of Na2SO4 are in 0.175 moles? If there are 142.042 grams in 1 mole. So I take 142.042 times it by 0.175. 24.857. Now this guy has 3 significant figures, so this guy should have 3 significant figures. So our answer should have 3 significant figures. And since this is our answer, we can write 24.9 grams of Na2SO4. And there's our answer. Right? That's a simple 2-step stoichiometry question. It takes me about 5 minutes to do it while explaining. So convert. Step 6. Check sig figs. And number 7, check units. All right, so we're going to go through that process with all of these. All right, here we go. Next one. In photosynthesis, plants use energy from the sun to produce glucose, C6H12O6, and oxygen from the reaction of carbon dioxide and water. How many molecules of glucose are produced when 3 moles of water react with carbon dioxide? Step 1, balanced chemical reaction. So we need to write this one out ourselves and balance it. We've got CO2 plus H2O. It's going to give us C6H12O6 plus O2. Not a fun one to balance because we've got, let's do our O's last, right? Because we got O's there. So C's, we need 6 C's here to get that. We're going to need 6 here to get our hydrogens up. All right, now let's look at how many oxygens we have. We have 12. We have 18 oxygens here. We have 6 oxygens here, and we have 2 here. Well, we have 18 oxygens here, right? 6 times 2 is 12, and 6 times 1 is 6, 18. Let's get this to 18. We've already got 6 here, so we need to get this guy up to 12. Right, so let's get him up to 12 with a 6. 6616. That's balanced. Step 1. Balanced chemical reaction. Step 2. What do we know? We know 3 moles of water. 3.00 moles. That's our known. Step 3. What are we trying to find out? How many molecules of glucose? How many molecules? I'm going to say particles. That's what we're trying to find out. Here's our chemical reaction. Here's what we know, 3 sig figs. Here's what we're trying to find out. Next step, let's map it. We start out with our moles of H2O, which is going to be 3.00, 3 sig figs. Then we can go through our molar ratio. We can go to the moles of C6H12O6. Now let's write our molar ratio out. It's 6 moles of water to every 1 mole of C6H12O6. Then we can go from our moles of C6H12O6 to our particles of C6H12O6. And we do that using Avogadro's constant, 6.02 times 10 to the 23rd. Right, so I'm going to do my first step here. So I write down how many moles of C6H12O6 are there for every 3 moles of H2O if there's 1 mole of C6H2O6 for every 6 moles of water. So I do 3 times 1 divided by 6, which is just 3 divided by 6, which is 0.5 moles. We'll have half a mole. Do you see how this is 6 times more moles than this one? Right? 6 times more moles than this one. Now we go to our particles of C6H12O6. And I write out how many particles will there be in half a mole if there are 6.02 times 10 to the 23 particles in 1 mole, Avogadro's constant. So we do 0.5 times that, and we are going to get an answer of 3.01 times 10 to the 23rd power particles. Now, this guy had 3 significant figures, so I kept this guy to 3 significant figures, and then this guy also has 3 significant figures. There's our answer. These are two-step stoichiometry questions. The only thing that's new from the last section is this bit right here. This moles to moles conversion from our chemical reaction. That's the only thing that's new. This conversion you should know how to do from last section. All right, let's take a look at the last example. When 84 grams of methane burns in oxygen gas, how many moles of CO2 will be produced? So step 1, chemical formula. We've got methane gas, CH4 plus O2 gives us CO2 plus H2O. There's our chemical formula. Now let's balance it. 1C, 1C, 4 H's. We need 2 there. Then we need a 2 here for oxygen to get us up to 4 oxygens. 1, 2, 1, 2. Balanced chemical reaction. Next thing, what do we know? Methane. We've got 84 grams of methane. So we're going to need to know the moles of methane. What are we trying to find out about? How many moles of CO2? Well, that makes it easy because that's one less conversion. So let's map it out. Step 1. We know the mass of CH4 is 84 grams, 2 significant figures. We can go to the moles of CH4, and we do that using our molar mass. Then we go from the moles of CH4, then we can go to the moles of CO2 using our molar ratio. And our molar ratio is 1 mole of CH4 to 1 mole of CO2. Well, this is nice. This means that this number is going to be the exact same as this number, so we don't have to do this second conversion. It just transfers right down, right, because it's a 1-to-1 ratio. So we do our first one. All right, I need to know my mass, molar mass of CH4, 12.011 plus 1.008 times 4, 16.043. So, how many moles are in 84 grams of CH4 if 1 mole has 16.043 grams? 84 times 1 divided by 16.43, so 84 divided by 16.043 equals 5.235, and it should have 2 significant figures. 5.2 moles. Normally, I would keep more significant figures around in case I need to do more math, but because I know that my answer is the same down here as up here, because it's a 1-to-1 ratio, I just have my 2 significant figures. 5.2 moles of CO2. That's our final answer right there. Those are the steps involved in stoichiometry questions. All right, I hope you understood how this works, and I hope you'll be able to do this on your own. That's the hard part, being able to do this on your own. We'll go through the rest of these examples in another video. All right, thank you for watching.